right? So this is real world boots on the ground. Our program is actually giving real results. So at this point, it's about expanding the product. This is no longer a concept. This is a product now.
So you've run it on an existing, like something that's currently live.
Yeah, correct.
Okay.
Correct. Something that's currently happening. It is an email extortion scam. Essentially, somebody sends an extorting email claiming to have, sensitive, compromising images or videos of whoever they're sending it to, and then they say, in order to get me to stop, you have to send me this much Bitcoin. So, here, let me share. We've prepared a couple slides, and then I'll be sharing my screen, and we'll be going over all the results. So, let me share my screen.
It's like with the iron, is it like the iron drop, my airdrop last week? I think it was like through email, someone hacked 4 or 5 million or something like that.
Yeah, yeah, these kinds of scams are very, very prevalent. So, of course, being able to work out something of this nature to be able to expose such scams would obviously be very, very useful. So this is where we were at last time we met. We were discussing our approach and our methodology, right? So this is kind of the general design of our algorithm. Then we went over, okay, how is each step going to happen? And we had run dummy runs where we were essentially testing our, multi-hop analysis capabilities and the tagging and tracking capabilities. But now we come here to our actual runs. What you're seeing here on the right is the network, the flow of funds for a currently running scam. Essentially, what I did is I took this email extortion scam and see, our problem is we have the tagging abilities, right? We have the multi-hop analysis capabilities. What we're missing was a seed list to begin with, right? Now, generally, we were expecting that, okay, if we're dealing with some firm or some kind of external client, they provide us that. But now it's kind of like a catch-22 because for this proof of concept, we have to provide ourselves this list. So what we did is we ended up finding two sites, Bitcoin Who's Who and chainabuse.com. Here, users provide manual reports. So if they're the victims to some kind of cryptocurrency scam, they will manually post a report to this site. So what I did is I wrote a scraper for this site to return data that's on it, right? So here what I did is I begin with the addresses tied to a certain scam, which is this, an email extortion scam. So this email extortion scam, I essentially pulled out the addresses that are connected to it. Now in my proof of concept, what do I need to show? I need to show that if I begin at a subset of these addresses, I can recover the rest of them simply using my multi-hop analysis here, right? This is what needs to be shown. And when I ran this, the algorithm was so effective that not only did I recover the full list of addresses that I know were tied to this scam, I actually got hold of other addresses that have existing reports on these sites and was able to show tangible connections between them. So
So
here,
so
what you're
you
seeing,
just to be clear on that, so you were able to cross-reference the addresses post running the algo with those which were reported on some of these sites. Okay.
yes, exactly, exactly. Which then shows that our algorithm is really working. It is really pulling
Yeah.
out this data.
Validates it.
And what else does it goes to show? It also goes to show that there must exist wallets that are engaging in malicious activity that don't have existing reports. And this is where our algorithm can pull out ahead of the rest and actually return real useful data, the kind of thing somebody would pay for, right?
Right, right.
So, uh, and the point I really want to make, and the point I really want to emphasize throughout the entirety of this entire presentation, is that this is happening completely automatically. Generally, to run investigations like this, you need a large team of people, right? And these people will go through the transactions. And again, each of these people is on the clock. Each of these people is being paid a salary to carry out this investigation, right? In more traditional firms, these investigations are generally carried out by teams of people that are cross-referencing data. Here, the algorithm is doing everything on its own. I am clicking start and the algorithm is going from top to bottom completely on its own. And it's obviously taking much less time and much less resources. The entire investigation you're about to see here is something my computer came up with in about hour and a half. And this is not like a very advanced computer that I'm running this on. Most of my time comes from the fact that I'm using the free version of many APIs. So
Yeah.
really, theoretically, that time can be stretched down way, way further, right? So now let's move on to the next slide here. So once I have this full network, once I can understand this flow of funds, what I can do from here is I can isolate large players in the network. And this is really simple. In fact, once you have this, your large visual database of the involved wallets, this is really just a matter of running one cipher command, right? To isolate wallets that are connected to transactions that are very large. So what you're seeing here on the right now is these are wallets that are tied to transactions that are greater than or equal to about 0.1 Bitcoin. So that would be about 6 grand, right? Which is like a sizable transaction, right? And what we'll see when we switch over, and I will actually show the current status of our visual database, is that some of these transactions get massive. There are single transactions within this database that go up to 10, 17 Bitcoin in a single transaction. So there are very massive transactions in our database here. Now, transaction chaining. We already have the tagging algorithm that uses external data, but we also are now working on an algorithm that looks at the smallest chain between a certain wallet and a marked wallet. If I see that, I don't have any information on a specific wallet, but if I can see that it's very closely tied to three different wallets that are marked, and there's a large amount of funds moving between them, I can now very likely say that this wallet is suspicious as well. And this is a way in which we can expand our tagging algorithm and catch even more wallets. Here on the right is a real example of this transaction chaining process. And this I'll go over in more detail once we switch over to my backend. And then we'll go over this, right? But again, the main points to stress here is that this is happening completely autonomously, right? Even finding this chain is being done by the program. I'm telling it what wallet to look at, and it finds the chain, right? So, and again, this is not complex. If you look at it from a computer science point of view, this is just a pathfinding algorithm. Once we have our visual database, this is just running a pathfinding algorithm on it, which is not very complex and has its own history behind it, right? So now we're going to switch over to some results, and essentially we're going to make this a little bit more real world, right? I've shown you some of the results, but we're going to make this a little bit more real world, right? Here we can see an example of me running this scraper that runs over these sites that Chain Abuse and Bitcoin Who's Who. So essentially here I use my Neo4j handler to return the list of all wallets in my database, and then I use my scraper to check whether these wallets have existing reports. And it will tell me if they do. And here we can see I provided a subset. So the subset I provided was this wallet, and I think it was this wallet and this wallet, these three. And it recovered every other wallet I needed it to find. But it uncovered more wallets. And this kind of showed me that there's a connection between the scam that we were studying, this email extortion scam, and other scams as well, right? And finding a connection
Sure.
like this is huge because then this is evidence of a conspiracy, right? This is evidence of some kind of larger operation happening, right?
Right,
So
right.
here we can come to our so here we can see the original chain abuse report from which I begin. And again, keep in mind, this massive database over here, which contains many hundreds of wallets, is just 5 hops away. This was only 5 hops. I began with this wallet from one of these reports, and in 5 hops, I was able to generate this massive database upon which this entire investigation is done. So it goes to show the power of this algorithm. You can just click play on a computer, and in half an hour to an hour, it will be able to do thoroughly what would take a team of people days or even weeks to do.
So when you're identifying the
Mhm.